Hello everyone, I am Rupagde. Today I am going to discuss what is the tangent plane and how we use the concept of the partial derivatives to find the equation of the tangent plane to the surface at a point, and how we use the concept of the gradient of a function, gradient vector of a function to find the equation of the tangent plane to the surface at a point. Clear? So let's try to understand this kind of problem first. After that we try to solve it. Okay, so this problem also asked in JAM 2020. Okay, so given problem is, if the equation of the tangent plane to the surface z equal to 16 minus x square minus y square at the point P of 1, 3 and 6 is ax plus by plus cz plus t equal to 0, then the value of modulus of d is option A 16, option B 26, option C 36 and option D 46. So this is the problem on the concept of the tangent plane. Okay, so let's try to solve this kind of problem. Okay, so I always start with how to solve this kind of problem. So how to solve? First, recall some basic fact. Clear? So now the equation of the plane at a point P whose coordinates are x0, y0 and z0 with unit normal vector or with normal vector whose components are A, B and C is given by A into x minus x0 plus B into y minus y0 plus C into z minus z0 is equal to 0. So this is the equation of the plane which passes through the point P whose coordinates are given by x0, y0 and z0, normal vector n whose components are respectively A, B and C. Then the equation of the plane is given by A into x minus x0 plus B into y minus y0 plus C into z minus z0 is equal to 0. So this is the equation of the plane which passes through the point P and having a normal vector n. Clear? Now number 2. What is the gradient vector of a function f? The gradient vector of the function f is given by gradient of f whose components are fx and fy and fz. And what is fx, fy and fz? Fx is nothing but this is equal to del f del x, this is equal to del f del y and this is equal to del f del z. Clear? So what is del f del x? We take the partial derivative of the function f along x direction or x axis, and here we treat y and z are also constant. And similarly, when we take the partial derivative of the function f with respect to y, then we take the derivative along y axis or along the y direction, and here we treat x and z are also constant, and we take the derivative of the function f with respect to z, then we take the derivative along z direction or z axis, and here we treat x and y are also constant. Clear? So this is the concept of the partial derivative of the function f with respect to x, y and z respectively. Clear? So this is the partial derivative of the function f. Okay, now the gradient vector is also the orthonormal to the surface. If you consider the surface f of x, y, z is equal to k, where k is a constant. Okay, k is constant. Then gradient vector of this of the function f is also orthonormal to the surface. Okay, so this is the so sometimes this gradient vector is also called the normal line to the surface at a point. Clear? So this is the surface and this is the gradient vector, and if you consider the equation of the tangent plane, which at point P, whose coordinates are x0, y0, z0, is given by fx at point P, x minus x0 plus fy at point P, y minus y0 plus fz at point P into z minus z0 is equal to 0. So this is the equation of the tangent plane which passes through the point P. Okay, and sometimes this tangent plane is also called, this is the equation of the tangent plane. Okay, this is the tangent plane, and sometimes this tangent plane is also called the linear approximation. Sometimes this tangent plane are also called the linear approximation. Why the tangent plane is also called the linear approximation to the surface at a point P? Because tangent plane is also nearly approximate to the surface, to the any surface f at a point P. Clear? So that's why sometimes tangent plane is also called the linear approximation to the surface at a point P. Clear? So using these two concepts, we solve this problem. Okay, we try to solve this problem. Now our equation is, that is surface is equal to z equal to 16 minus x square minus y square. So now we introduce a new variable w, which is w is the function of x, y, z is equal to x square plus y square plus z. Clear? Then our surface is the level surface w of x, y, z is equal to 16. This is equation 1. So this is the equation of the surface. Now we find the gradient of w. Now we find the gradient vector of the function w. This is equal to wx, wy and wz. Now we find wx, wy and wz. Now wx is equal to del x of w, that is equal to del x of x square plus y square plus z, and here we treat y and z are also constant, so we take the derivative along x variable. Okay, so this is equal to 2x. Similarly wy is equal to del y of x square plus y square plus z, and this is equal to 2y. Clear? And similarly wz is equal to del z of x square plus y square plus z. This is equal to, here we treat x and y are also constant, so we take the derivative along z variable. Okay, so we find this value is equal to 1. So this is wx and wy and wz. So we find gradient vector of w is equal to, we find gradient vector, this is equal to wx, that is equal to 2x, and wy, that is 2y, and wz, that is 1. Clear? So this gradient of w is also the perpendicular or orthonormal to the surface w. Okay, so This is also the orthonormal to the surface. Okay, this is also orthonormal to the surface W. Clear? Now we find gradient of W at point P, that is equal to 2 into 1 into 2 into 3 and 1, because P, the coordinate of P is equal to 1, 3 and 6. So we find gradient of W at point P is equal to 2, 6 and 1. Clear? So finally we find gradient of P, gradient of W at point P equal to 2, 6, 1. So this is equal to 2, 6 and 1, and P is equal to 1, 3 and 6. Now we find the equation of the tangent plane at the point P. Now the equation of the tangent plane is also given by Wx at point P into x minus x naught plus Wy at point P into y minus y naught plus Wz at point P into z minus z naught is equal to 0. Clear? So we find Wx is equal to 2 into x minus x naught, that is 1, plus Wy, that is equal to 6, and y minus y naught, that is 3, plus Wz, that is value 1, into z minus z naught, that is equal to 6. This is equal to 0. So we find, multiply this, we get 2x minus 2 plus 6y minus 18 plus z minus 6 is equal to 0. That is equal to 2x plus 6y plus z minus 26 is equal to 0. This is of the form, this is the equation of the tangent plane at the point P, whose coordinates are 1, 3 and 6. Now this is of the form ax plus by plus cz plus d is equal to 0. Okay, comparing the coefficient of these two equations, we get d is equal to minus 26. So we find d is equal to minus 26. So if d is equal to minus 26, then we find modulus of d equal to modulus of minus 26, that is equal to 26. So option B is also correct. Clear? So option B is correct. So this is the way to approach this kind of problem. Okay, so I hope you got the idea, and thank you very much, and take care, and subscribe my channel for more update, and again thank you. Take care.